All right, good morning. It's right at 8 o'clock, so we'll go ahead and get started. Um, just like last time, the session is being recorded and will be posted for later viewing if you're unable to make it, or if you just need to go back and review something that we went over. So what we're going to do this morning is really focus on inheritance and encapsulation, which is really the material from week 3. Now, week 4, which is this week, is a lot of GUI stuff, showing windows and drawing windows and stuff like that. We're not going to touch on that too much today, unless there's a specific question. The reason why I'm going to focus on the week 3 material is because that is what your assignment is focused on. For your assignment for this week, there is no kind of GUI work or anything like that. Your next assignment in week 6 does have you create windows and other UI type elements. And so whenever we get to that week for a Zoom session, we will cover all the UI stuff. So for today, we'll just focus really heavily on the inheritance and encapsulation of Java classes, so that it really helps you out for your assignment. So what we'll do is we'll just kind of do an example, a live example here. And as we're doing the example, I'll explain all the different various pieces of it, and you'll see how we create some Java classes and how we use inheritance to make those classes work out for us. So the last time we talked about Java objects, right? What is a Java object? What is a Java class? A Java class is just code that represents some kind of real world object or real world something that we want to do. So we'll start out with that same concept. We want to make a class for a car, right? So let's not think about inheritance yet. Let's just think about a car itself, because we need to create a starting point, a base class is what we call it, or a super class. So we'll start with that first, and we'll call it a car. So with an object, you have variables that kind of describe the makeup or the state of that car, right? So what are the variables that we need to describe a car? Well, we can have a string that maybe it's the VIN, right? The VIN number for the car. What else does a car have? A car can have color. What else describes a car? Private string. We'll have the make of the car. You can think of it as the make and the model. We're not going to have a ton of variables here, but maybe you have another one that's the model as well. Let's see, we can have the number of miles on the car and the year the car was made. Those are some things that can describe a car, right? It's not all encompassing. There are other things about a car, right? But for our example, I think that's pretty good about how we can describe a car. So we'll make a little comment here. These are our variables, if I can spell right. There we go. That's our variables. So the first method you should make with a new Java class or a new Java object you're making is the constructor. Remember, the constructor is what gets called whenever you do new. Construct. I'm having a problem spelling this morning. There we go, constructor. And it looks like this. The method is public. It has the same name as the class. And the parameters you want to give it are what you need to know in order to initialize all these variables to known values. So if we don't give it any information, we still need to set some known starting values. So the VIN, we'll just make the VIN blank. The color will be blank. The make will be blank. the miles will be 0, and the year is 0. All right, but that's not very helpful, is it? I mean, because whenever you make a car is always going to have a VIN number. It's always going to have a color. It's always going to have a make. It's always going to have miles. And it's always going to have a year, right? So having a constructor with no parameter really doesn't make a lot of sense, because you need to know what these things are, right? So let's give it as parameters. Give it the VIN, give it the color, give it the make, the miles, and the year, right? So instead of setting them to be blank, we'll set it to be the variables that are passed in as a parameter. Make, the miles, and the year. So you see, whenever we do this dot a variable name, we're talking about these class variables here. It's this object, this car's VIN, this car's color, et cetera, et cetera. And so that's why you could have these be the same name. For example, the class variable is VIN, and the name of this variable as put as a parameter is also VIN, but you can differentiate them by saying this dot VIN, which represents the class VIN variable. And then just VIN by itself is talking about the one passed in as a parameter. Okay, so that's a basic car right now. Excuse me, we're going to expand upon this. But right now, let's go ahead and make a car, right? So let's go to our main method. Let's make a car. We'll have a car, call it, we'll make a new car. And can we do that? The answer is no. You know, my IDE is giving me a red squiggly. If I try to compile it, you know, it tells me there's an error. And that's because it's expecting a bunch of parameters in here, right? You know, if we look back at it, we got to give the constructor all of that information, which is the VIN, color, make, miles, and year. So let's give it a VIN. Let's say the VIN is ABC123. I already forgot what the order of them was. The VIN, the color, and the make. Say the color is red. The make is a Toyota. The number of miles is 2345. And the year it was made was 2019. Okay, so we've made a new car out of this class that we just created. Well, let's print out the car just so we can see what's there. Car. Does anybody know what's going to happen here? It's going to print something out, but it's not going to be very useful. And this is kind of a rehash from what we did last time. So let's run it and see what happens. There we go. It printed something out, but that's not really very useful, right? Really what this is doing is telling us it's a car class, and that's the memory address where it's located in memory. That doesn't do us a lot of good, right? We want to be able to print out, you know, the description of the car, right? So how do we do that with the Java class? All Java classes can have this method called toString. And what you can put in here, you can just have it return a string. You can build up some kind of string here and return that string. And whenever you do, whenever you try to print a car, that's what it'll use. All right. So let's just make a string S. We'll say it has the VIN. VIN plus print out a few things. Do the VIN, the color, the make, the miles, and the year. VIN, color, make, miles, and year. And we'll put a tab. I'll tell you what these represent in a second. what we did, we just made a two-string method. We're going to build up this string. The string S is equal to all of this stuff here. Let me make that go away. So it stops complaining. There we go. So the string S is equal to all of this string type stuff. So what am I doing? I'm just saying the VIN plus the VIN variable. The \n just makes a new line. It just returns to the next line. And the \t actually makes a tab. So we'll be able to see this here in a second whenever we do it. But all it's going to do is just, it makes a string with all of this information and it returns that string. So now whenever we try to print out this variable, we have a car. It's this new car with all that information. And now when we print it out, whenever we try to print it out, it actually uses this two-string method to figure out what to print out. So now let's run it. We should get something useful. There we go. Look back at car. See, we have the VIN and the VIN on one line, which is right there. Then we go to the next line, and then we tab over and we print out the color. We go to the next line, we tab over, we print out make. Oh, I've actually made a mistake here, haven't I? That's the VIN. That's when you print out the color, print out the make, print out the miles. There. So instead of printing out the VIN for all of it, we should actually print out the correct variable. And let's run it. And now it should look right. There we go. So this is printing out our car. Okay. So far, so good. So far we have a class. We have these variables that describe what this car is. We made a constructor so that whenever we make a new car, we initialize all these variables to something. We have this two-string method so that whenever we want to print out a car, it prints out something meaningful. All right. What other methods should we make for our car? For any just generic car, think about things that you can do with that car. Okay. So let's say you can drive the car, right? That's something you could do with a car. So let's make a new method called drive. It is marked public because I want to be able to access it outside of this class. I want to be able to use it for main. It's void because I'm not going to have it return a value. It's just going to do something. And then the name of it is drive. So if we drive the car, what do we think should happen with the car if we drive it? All right, well, if we got this variable called miles, so if we drive the car, we need to add some more miles to the odometer, right? So let's add some more miles. Say if we drive it, we want to add 10 more miles onto it. And we'll expand upon that. Miles equals to plus equals to 10. There we go. If you're not sure what the plus equals means, it means just add 10 onto this already existing variable. These two things, those two things are the exact same thing. The plus equals is just a little shortcut. So I like to use it. So let's say if we drive our car, then we just add 10 miles onto it. Okay, let's test it out. So if we have a car, we're going to print out the car. Let's drive the car, and then let's print out the car again to make sure, the change happened that we wanted to happen. Let's run it. There we go. So we have our car. As you can notice, the miles start out being 2, 3, 4, 5. That's right here after we create the car. Now we're going to drive the car and print it out. And when we do that, you can see the miles went up 10 10 miles, right? So far, so good, right? Except, do you always drive your car 10 miles at a time? No. You drive a certain distance, whatever the distance is to your destination. So let's make that as a parameter here. Let's make it a parameter, number of miles driven. Okay. So we'll have a parameter to drive that says this is how many miles I drove. So instead of just adding 10, we'll add on the number of miles that we drove. Now my IDE is warning me I've created some kind of problem. What is the problem that I've created? Well, this is fine. But if we look back at our main, our drive is now complaining to us. And likewise, if you're not using an IDE, if you're just, say, using Notepad, whenever you go to try to compile it, it'll give you an error and saying you did something wrong. It's on this file, on this line. So on line 9, here's where the problem is. And that's because our drive method is now expecting you to tell it how many miles you drove. So we'll say we drove 2 miles. And then we'll do it one more time and we'll drive 22 miles. And each time we're going to print it out. That way we can check if it's working properly. Let's run it. There we go. There's our car when we first create it, has 2, 3, 4, 5 miles. Then we drive the car 2 miles and print it. So you can see the miles went up by 2. 2, 3, 4, 5 to 2, 3, 4, 7. Then we went to drive the car 22 miles and print it out. And there you go. You can see it went from 2, 3, 4, 7 to 2, 3, 6, 9. So it is now increased by 22 miles. All right, so this is telling us our drive function is working just fine. Let's do one more method and then we'll start getting into inheritance. So let's make a method to compute the tax that we owe on the vehicle. Every year you got to pay vehicle tax to your state, right? So let's make a method to compute how much tax do we need to pay for our vehicle. Let's make it public because we want to be able to access it from our main method. It's going to return a float. That is the return type. And why? Because we want it to tell us, what is the cost in dollars and cents that we owe for the tax. I could make it double. I could. There's nothing wrong with that. I've been programming long enough that I'm from some old day programming where computers weren't as powerful and they didn't have all of this memory. And so you had to worry about the amount of memory your program was using. And so a float actually only takes 4 bytes of memory. A double takes 8 bytes of memory. So I'm just very accustomed to using float, but there is no reason that you can't use a double here because they both just represent a fractional number, right? But for me, I like using float. And then we need to name the function. We'll name it compute tax. And then is there any parameter we need to give it? Well, we'll see in a minute, right? So how do we compute the tax on the vehicle? I don't know, every state's probably different. For us, we're just going to say it is how old your vehicle is times the tax rate. All right, let's just say that's what it is for our example. That's probably not a realistic formula, but for us, that's going to be the formula. Let's just put it in plain English. The tax is how old the car is times the tax rate. All right. So let's put that into Java. So the tax will be equal to how old the car is. So how do we compute how old the car is? Well, it's just like you compute how old you are. You take the current year and you subtract the year you were born, right? And then you all right, so that's how you can compute how old the car is. Like I said, that's just like computing how old you are. And then times the tax rate. Let's say the tax rate is 10.2. I don't know. Right? And then let's return the tax. RETURN. There we go. And that's it. Right? So to compute the tax, it's just how old the car is times the tax rate. Like I said, I don't know if that's a realistic formula, but that's the formula we're going to use. All right. So let's go back into our main and let's use this compute tax. Remember, it returns a float. Let's go back here. Let's get rid of all these other cars. So now let's print out what the tax rate is. We'll just say system.out.println you owe in tax, or your, just say your tax bill is car.compute tax. And we can just do it like that. And why is that? So we're just going to print out a string, and the string is going to be the actual text, tax bill is, plus whatever this is. And whenever I say whatever this is, that means this has to return something. And we've already seen that it returns a float. So whenever we have this car.compute tax, you can think about it as this actually represents a floating point number. It represents a float. And we can add a float and a string together. And Java is smart enough to just make that into a string. So let's run this. And just give us the right thing. The tax bill is 30.5999998. Is that correct within a floating rounding error? It actually is, because if we look at our year is 2019 for the car. So let's look at our little formula. So it's 2022 minus 2019, which is 3. So it's 3 times this. 3 times 10.2 is 30.6. And that is within the rounding error. So it is computing the right thing for us. And if you want to know why it doesn't say exactly 30.6, I actually did post a video in the course announcements talking about why computers, any binary computer, it's not a problem unique to Java, but any binary computer has this problem with representing floating point numbers. And so we kind of see that here. But it's really outside the scope of this morning's discussion. It's really outside the scope of the whole class. I just put it up there because I think it's interesting and because it can help explain why you may not get exactly what you think you should be getting, but that's really close, right? Okay, so that's the compute tax. Well, let's make it a little bit more flexible, just like whenever we did drive and we put in the number of miles driven. Let's also, for our compute tax, as a parameter, let's give the tax rate. So instead of having this hard-coded number here for tax rate, make it a little bit more flexible. That means we can call this function with any tax rate we want. And so now you can imagine, if there are different states that are using our software that we've written, each state probably has a different tax rate. And so now every state could use our software because we're letting the user tell us what the tax rate is. All right. So like I say, it creates a problem, and the problem is right here with compute tax, because the compute tax is expecting a tax rate. So now let's make the tax rate 2.1. Let's run it. You see the tax bill is basically 6.3. We could change this to something different. Say the tax rate is 2.9 and we run it. And now there you go. That's what your tax bill is. $8.70 with a little bit of a rounding error, like I said. Okay. So let's look back at our car one more time, and then we're going to start talking about inheritance. So it's our car class. These are the variables that describe what a car is. I do see your question in chat, and I'll get to it in a second. This is the constructor that takes all of these parameters. It's going to take as input the VIN, the color, the make, miles, and the year. And then it just sets up the internal values of these variables. We have a public void drive method. Public means I can access it from somewhere else. Void means it does not return a value. Drive is the name of the function of the method. It has one parameter, which is how many miles we drove. And then all it's going to do is update the internal state so that the miles for this car now increases by how many we drove. We're going to have another method called compute tax. It returns a float. What it's going to do is going to compute what the tax is that we owe on the vehicle. And we're just using this super simple formula. And so we just compute that formula and then return it, because we said we're going to return a float, and here we are returning the float. And then lastly, we have the toString method that just takes our class and makes a string out of it that can kind of accurately represent it. Now, you don't necessarily have to print out all of the variables. Let's say you could leave out the make if you wanted to, and that would work just fine. Now, if we ran it, it still works fine. It's just we're not printing out the make anymore. But for our example, we're going to keep it in there for our toString and show you it works. And it works. Okay. So before we get to the inheritance, question about what is the F behind the number when you type it? Does that mean float? And yes, it does. So you see here, whenever I have this tax rate, so let's delete for now. When we look at our compute tax, it's expecting as a parameter a floating point number and the tax rate. So compute tax wants us to give it a float, right? So for tax rate, if we put just 2.1, if you do not have the F there, this looks like a double to Java. Java assumes it is a double. Okay. And so what you're doing, you're trying to give it a double when it's expecting a float. And that causes problems. So if you explicitly want a float, you can put the F behind it, and it tells Java that this is a floating point number. Okay, so that's what the F represents. It's just the difference between a double and a floating point number. Okay, so let's talk about inheritance. So inheritance is when you want to create a new Java class, a new Java object, but you want to base it on an existing object. And what do I mean by that? So let's think about our car, right? A car is really just kind of generic, right? You can have all kinds of different cars, right? For our example, we're going to talk about a gas car and an electric car, right? So when you think about it, so you have a car which is just a baseline generic car, but you have a gas car or an electric car, those are still cars, right? A gas car is a car. It's just a little bit more specialized, right? Meaning it has a gas tank and an ICE engine, right? An electric car, it is a car. It does everything a car has. It has everything a car does, except it's a little bit more specialized. It has an electric motor. It has a battery charge, right? So you can kind of think of these in parallel with each other, meaning you can have a basic car, but then you can get more specialized, and you can be more specialized as a gas car or more specialized as an electric car. So let's make a new class for a gas car, and we want to base it on our existing car, but we want to add a little bit more specialization to it. So let's make a new class called a gas car. So we have the class gas car, and we want to say it extends car. When I say it extends car, that I'm telling Java this gas car, it is a car. It has all of the variables that a car has. It has all of the methods that a car has, but I'm going to make it a little bit more specialized. I'm going to add additional specialization to it. Just make a comment. It'll be the additional variables. So when we look at it, it extends car. You know, our car has all of these variables, right? Our car has a VIN, a color, a make, a miles, and a year. Gas car also has all of those variables. And the thing is, I don't have to repeat them here. All I need to do is make the new variables that represent a gas car. And really, the only one I'm going to add for a gas car is how many gallons of gas it has. Right? That's what makes it a little bit more specialized, right? There's other things in there, you know, as far as it has a different kind of engine and stuff like that, sure. But let's keep it simple and just say a gas car is a car. It has everything a car has, plus it has this new description, this new variable about how many gallons of gas are in the car. Gallons of gas. There we go. All right. It also needs a constructor. I'm having problems spelling this morning. There we go. There we go. Has a constructor. So it's going to look like this. Gas car. Okay. But it still needs all those parameters, right? What's happening here behind the scenes is it's also creating the base class. Let's do a little bit of terminology first. So gas car is what we call the derived class. That means it is it's kind of, think about it as like a child-parent relationship, I guess. That's not exactly right, but it's close. But a gas car, like I said, is a car, just more specialized. So whenever we construct a new gas car, the base class is also getting constructed. What the super represents this base class, this car. So whenever we construct a gas car, we're also constructing the super class. Super class is what you are extending. And so you can think that this is calling the constructor for the super class. Well, let's look at the constructor for the superclass. Superclass is car. The constructor expects all of this stuff, right? So whenever we construct the superclass, we need to give it all that stuff. We need to give it a VIN, was it a color, a make, miles, and year, right? It needs all that information, right? Whenever we construct the superclass. Well, the thing is, just like when we made this constructor for car, at first we just used, I just typed in some values, right? But that's not useful because every car is going to be different. Same thing here with the gas car. We really need to take those as parameters in our gas car constructor so that whenever we make our superclass, we can just pass those right along to it. This is constructing the superclass, which is car. Constructing the car superclass. That makes more sense. So there we go. We're going to construct the car superclass. And we do that by using this super keyword and then giving it all the parameters that the car class needs. There's one more thing we need to do here in the constructor, one more loose end. We have this new variable called gallons of gas. We need to set it equal to some value. We need to initialize it. What do we set it equal to? Do we do it in the car class? We can't do it here. Why can't we do that? Make gallons of gas here. It's because in car, there is no gallons of gas, right? This is all we have in car. So car has no gallons of gas. So it can't go there. We have to do it in the gas car because this is the only place this variable exists. Like I said, when you extend car, this class gets all of those variables from car, but it does not go the other way. That means gallons of gas does not exist in car, but all of the car variables do exist in gas car. That's what it means when you extend it. And not just the variables, but also the methods. And we'll see that in action. So here, in this one is where we need to set it. Let's say it has 10 gallons of gas. But I don't like to use absolute numbers like that. So let's make it another parameter to this constructor. Right? So now we can set it like this. All right. Let's talk about what we did. So we made a new class. We made a gas car. It extends car. That means it is a car. It's just a more specialized version of car. It has all of the same variables that car has. I don't have to explicitly type them out here, but any variable that exists in car, it exists here in gas car. Any method that exists in car, it exists here in gas car. Okay. So, and we add on a new variable called gallons of gas. That's what makes this more specialized. So we have the gas, the gas car constructor. We pass it all of these parameters. We call the superclass's constructor. The superclass is car. So that's doing the car constructor. And we're giving it all of the parameters that it expects. And then additionally, we have to initialize our own variable, which is right here, gallons of gas. So let's make a gas car real fast. in our main. So instead of car, let's make a gas car. And then we'll print that out instead. Okay, so remember for the gas car constructor, it wants one more, what information does gas car want? It wants the VIN, the color, the make, the miles, the year, and the gallons of gas. That's something new. So let's add on, let's say it has 15 gallons of gas. All right, let's run this program and see what happens. Run it, and there we go. We get the same output right now. That's because we haven't changed the output yet. But even though it's a gas car, whenever we print it out, it's still printing out just like a car would. Let's think about why that, well, let's mention the tax and then we'll talk about why that works. So whenever we make a gas car and we print out the gas car, it prints out just like the car did. Whenever we compute the tax on the gas car, it computes the tax just like it did on a car. Now, in gas car, we don't have a two-string method. We don't have a compute tax method. Excuse me. We don't have them explicitly. So because I do not have a two-string method, what it does is it looks at the at the superclass and looks and see, does it have a two-string method? So in car, there is a two-string method. Like I said, any variable that exists in car, exists in gas car, any method that exists in car also exists in gas car because it extends it. It is a car. It has everything a car has, and then a little bit more stuff, some extra stuff, which for us is gas. Is gallons of gas. So again, even though I don't explicitly put a two-string or a compute tax method, it does have one that it inherits from car. So it'll have these two methods in there, even though I don't explicitly retype them out. And that's how I'm using them whenever I print out car and then I do my gas car.compute tax. It's using those methods that exist in car. Okay, so let's look at our printout for a second. So when we print out our car, this is actually printing out our gas car. There's still one more piece of information that's missing, right? What is it? So we're printing out the VIN, the color, the make, the miles, and the year. And that's fine for a car. But for a gas car, we also have this gallons of gas. We want to be able to print it out so we know how much gas is left in our car. Well, let's look at our car method. So here's where we make the string, right? Can we do this? Let's just add another line on here that says, let's say it's gallons. And the name of the variable was what? Gallons of gas. This doesn't work. If you try to compile it, it gives you an error. Why is that? Just like we mentioned a second ago, gallons of gas does not exist in the car class. There is no gallons of gas here, right? So we can't put it right there. If we want to print out gallons of gas, it has to go somewhere else. It has to go in the class that knows what gallons of gas is. And that exists in my gas car class. So how are we going to do this? And whenever we print out something, it uses the two-string method. So in gas car, we need a two-string method. Public string two-string. And now we need to make a string that represents a gas car. And how do we do that? Well, it's going to be about the same thing as a car. Really, it's going to be almost identical. But then we're also going to add on that gallons. All right. So this is what it could look like. This isn't the best way. I'll show you a better way. So there's two problems with this. Let's compile it and I'll show you it doesn't compile. There you go. It doesn't compile. Why is that? You know, my IDE is kind of complaining about the VIN, the color, the make, the miles, and the year, right? We don't have those variables here, but I did say that because we are extending car, they do exist. You know, all of these variables in car exist in the gas car. So why am I having problems? Well, it has to do with this private here. You know, we talked about before, there's really three kind of modifiers you can use. You can use public, which means it's accessible from outside the class. You can use private, which means it's accessible only inside the class, but there's a third one. The third one is called I can't even spell this morning. Protected, there we go. Protected means you can use it inside this class or any class that extends this class. So if we have protected VIN, I can't use that from my main method. I can't access that variable from main. Why? Because main is outside of the class and it does not extend it. It does not extend car. All right. But with it being protected, I can use it in any class that extends car. So if we look at our gas car now, since our gas car extends the car, and since the variable is marked as protected, meaning I can use it from a subclass, then it stops complaining. I can use the stop VIN. I can use color, make, miles, and year. So actually it'll work now. Let's run it. And it actually compiles and runs. And if we look at what happens, we're actually printing out the number of gallons now. So that ended up working, right? So now there's some things going on behind the scene, right? So in car, we have a two-string method. In gas car, we have a two-string method as well. It's the same exact name, and it has to be the same exact parameters. For two-string, there were no parameters. This is what we say where it overrides the method. That's just a key terminology to remember is overrides. Meaning in our base class, which is car, we have a method called toString. It returns a string and it takes no parameters. If we want to change that functionality in our subclass, then we need to make it return the same thing, have the same name, and have the same parameters, which it does. You know, here car is public string toString, no parameters. In gas car, we have public string toString, no parameters. So now, whenever we print it out, it's going to use that toString method, but it knows to use this one. Java knows to use this one because it's a gas car. The object is a gas car, and we're printing a gas car, so we're going to use the gas cars toString method. Like I said, if this did not exist, it would still look for this gas cars toString, but if it doesn't exist, it's going to use the superclass one, right? But it does exist now, so it's going to use this one. A question I have, so protected will extend the scope of the superclass variable to all subclasses of that class. Yes. Can you have a class that now extends gas car and inherits from both car and gas car? Yes, you can. You can think about it like this. What is a more specialized gas car? I don't know. I can't think of one off the top of my head. Let's just say a semi gas car. Well, we'll call it a semi truck. All right. We could have a class called a semi truck, and it could extend a gas car. Yes. You could absolutely do that. And then what you would have here, you would have a variable that represents a semi truck. Let's say it's the number of wheels or something, or we'll call it the cargo weight. All right. That's a variable that's making a more specialized semi truck. So a semi truck is a gas car, and a gas car is a car, right? But this is more specialized information, and then you got to make the constructor. I'm not going to go too far doing this one, but then you would have to you need to do the super constructor here. So now you're going to construct a gas car. So if we look at the constructor for gas car, it wants all this information, and you need to put all of that information in that constructor. I don't want to go too much more down that example. We've got some other stuff to cover, but yes, you can have many different layers of this inheritance. You don't have to stop at just one layer. So let's delete this semi truck off there. All right. All right. So far this works. Print it out again, just show you it works. It does. There's one more. I say it's kind of like a pseudo problem, meaning the code still works. But look what I've done here. With car, I have all of this code right here, right? Let's copy it. And a gas car, I have all of this code. Now they look nearly identical, right? If I put them side by side, they are nearly identical, right? And in general, in programming, you want to avoid duplicating code. Having code in multiple places that does the exact same thing is a bad sign. It's a sign that you've messed up a little bit. So let's fix this up a little bit to make it better so that we're not repeating the code. All right. So in our gas car, we're printing out everything that a car prints out, but we're also going to print out the gallons of gas, right? Let's take away that. Yeah. Where's that? There we go. So just like we used super here, this called the superclasses constructor, right? Well, we can call specific methods of the superclass as well. So if we look at this part of the string, the VIN, the color, the make, the miles, and the year, if we look at the superclass, it's making that string already, right? So let's take advantage of that. So for this one, it can be equal to the superclasses toString method plus the gallons of gas. We have greatly simplified it, and we have gotten rid of duplicate code. So let's look at what we've done. We're making a new string. It's going to be equal to the superclass's toString method plus some more information, right? So what is the super toString? All right, well, the superclass is car. If we look at car, it's making this string for us: the spin, the color, the make, the miles, and the year. So this super toString is going to be the color, the miles, the color, the make, model, and year. And then we're just going to add on to it the gallons. So let's run that. There we go. It still works. It still gives us everything about the car and everything about the gas car, which is the gallons. And I've eliminated that duplicate code, right? Okay. One more addition we're going to make on here is, let's imagine, well, in our car, we also have the thing called compute tax, right? And we computed the tax based on the tax rate and based on how old the car was. Well, let's imagine that for a gas car, if you have a gas car, you also have to pay $5 more or something. I don't know. Okay, so we need to change how the tax is computed, right? So in car, can I do this? Tax rate plus 5. I mean, but that does work. It does add $5 onto the tax, but we only want it to apply if it's a gas car, right? So we only want to add $5 if it's a gas car, not just a generic car. So how can we do that? Well, just like we made a new toString method, just like we made this new toString method, we overrode the superclass's toString method. We can also override the superclass's compute tax method. Remember, they have to look the exact same, meaning they need to have the same access, the same return, the same name, and the same parameters. Let's just copy and paste that and make sure I did it right. Pretty sure I typed it right. Yep. So now, just like we did with the toString, we use the superclass's toString method. We can use the superclass's compute tax method and then just add $5 onto it. So what happened here? So again, we have this car class. It has a method to compute the tax. It does some kind of formula and it returns the tax. So if I do not have this, that just makes a comment. That just makes it like the code doesn't exist. Let me just delete it so it's explicit, more clear for you. So if I don't have that at all, so whenever I do the compute tax method, it first looks in gas car. Does this have a compute tax method? It doesn't. So then it'll look in the superclass. Does the superclass have a compute tax? It does. So it'll use it. So when we run it, of course, we get just what we got before. That's the tax bill. But if it does have that method, it'll use this method. And so what we're doing is we're still computing the tax. We're going to use the superclass's computed tax, and then we'll add $5 onto it. So now when we run it, it's actually $5 more, right? The other time it was like 6.3. Now it's 11.3. So that worked. So now every time we have a gas car, it's going to owe $5 more. Let's kind of see that in action here. So let's have a gas car. We'll just call the make a gas car so we can differentiate between them. Let's just make a car, a plain car. VIN, color, make, miles, year. There we go. I think that's all I need. Oh, new car. And we'll print out the same stuff. Car. Let me see what we're doing here. All right, so we're making just a plain car with all that information. We're going to print it out, and then we're going to compute the tax on the car. Then we're going to have a gas car. Actually, let's make them the same year. Then we're going to make a gas car. We're going to print it out and compute the tax on the gas car. Let's run it. And there you go. With a car, that's the car printed out. Notice it's missing the gallons of gas. That's because a plain car doesn't have gallons of gas. And its tax bill is 6.3. And then we make a gas car. Notice it also prints out the gallons, and the tax bill is $5 more. And that's because in gas car, when we computed the tax, we said if you're a gas car, you owe $5 more. Okay. That's all there is to inheritance, is knowing that the key thing you have to remember is that whenever you extend another class, it means it is that class. It is the class. It is a car. It is just a more specialized car. I'm going to add new variables, or I'm going to add new methods and new functionality. But anything that existed in the superclass also exists here in the derived class or in the subclass. Okay, so all of the variables of car exist in gas car. All of the methods in car exist in gas car. Even if you don't explicitly state them, they do exist. Okay, we're gonna quickly add on to it, and then I'll let you ask any questions you may have. So, we said we had a car, and a gas car is a more specialized version. Another more specialized version could be an electric car, right? It could also extend car. It's not going to extend gas car because an electric car is not a gas car, right? But an electric car is a car. And instead of gallons of gas, an electric car probably has, the battery charge, right? And I use float because let's say it's anywhere between 0% to 100% charged, all right? We need to make the electric car constructor, and it's going to be almost the same as gas car. So let's copy and paste this. It's almost the same. So make an electric car constructor, but instead of gallons of gas, it's going to be the battery charge. We need to construct the superclass. So we need to construct car. Car's constructor wants you to give it the VIN, the color, the make, the miles, and the year. And just like with gas car, we constructed the superclass, and then we initialized any new variables we made. We also, in electric car, we need to initialize new variables we made, battery charge. Right. So now we have a gas car, which is a type of car, or we have an electric car, which also extends car. So let's go back here to main. So we'll make this an electric car. Say the battery charge level is 54.5%. I don't know. So we're going to have an electric car, and that's the parameters for it. Electric car. And I'm just making the make the same as what kind it is, so that whenever we print it out, we know the difference. All right. So we make an electric car. And we're going to print it out and compute the tax rate on an electric car. And then we're making a gas car, same thing, print it out, compute tax. So let's file and run it. And there you go. This is our electric car with the tax bill. This is our gas car with the tax bill. So there's kind of something missing here. And what is it? Well, with the gas car, we get it to tell us how many gallons of gas they have. For electric car, we want it to tell us what is the how charged up is the battery, right? So we got to do some similar work. In gas car, this is how we got it to tell us how many gallons of gas. You know, we overrode the two-string method. Then we let this superclass give us all of that string information, and then we added on the gallons. Well, the electric car is going to be almost the same. You know, the electric car is going to have a two-string. It's also going to use the superclass's two-string. Remember, the superclass is car. The car two-string looks like this. It just makes a string out of all the information. And then instead of adding gallons like you did for the gas car, we'll add the battery level. So now let's print it out, or let's run it. Here you go. Now with the electric car, we get what we want. You know, this is the information about the car, and now we have the battery charge level on there. All right. For the gas car, that's what we have, and we have the gallons of gas. Okay. Let's go back to main. That's that. That's that. Okay. We'll do one more thing, and then we'll open it up. No, that's good. I went through enough examples of it about how to use it. All right. So that is kind of what we talk about when we talk about inheritance encapsulation. One more quick overview, and then we'll ask questions. So we have this concept of this base class or this superclass called car. These are variables that describe the car. You can have public variables, private variables, or protected variables. Public means they can be accessed anywhere outside the class, and public is not something you want to use on your variables. Just don't do it. Just forget about public being available for variables. Private means it can be accessed only inside of this class. So if I made Vin private, it can only be accessed inside of car, nowhere else. It can't be accessed in my main class. It can't be accessed in my subclasses. But if I make it protected, that means it can be accessed in my subclasses, but it still can't be accessed in main. All right. There's our car constructor with all those parameters, and we set the variables. We have this method called drive, and that's what it does. We have a method called compute tax. That's what it does. And we have a method toString, and that's what it does. Then we made more specialized versions of car. We made a gas car and we made an electric car. So the gas car extends the car. That means the gas car is a car. It's just more specialized. And this is what's more specialized about it. It has gas in it. Okay. We make the constructor for the gas car. The first thing we have to do is call the constructor of the superclass. And actually, Java requires this to be the first thing that you do. If you try to put other code here first, it's actually going to fail. It won't compile. You know, my IDE is complaining. If you actually try to compile it, it's going to tell you the call to super must be first statement in constructor. So you can't, this call to the super constructor has to be the first thing that you do in your subclass constructor. So that's what we do. And then we also initialize the rest of the variables, the rest of the new functionality. All right. And then we override the compute tax method because we want to charge them $5 more. So in the gas car, we override the compute tax. We compute it by doing the superclass's compute tax, and then we add $5 and return it. We override the toString method, meaning we use the superclass's toString, and then we just add on the gallons. All right, that's it for gas car. For electric car, it extends the car. It is a car with more functionality. And this is the more functionality. It has a battery in it. And this is, you know, what the charge level of the battery is. We call the constructor of the electric car with all these parameters. So we construct the superclass. So we're constructing car. We give it all the information a car wants. And then we initialize the new functionality, which is the battery. We're going to override the toString method to do the super's toString plus add on the information about the battery. One thing you'll notice here is in gas car, we overrode the compute tax method, but we didn't do it in electric car. And the thing is, we don't have to. If we wanted the electric car tax to be computed differently, then sure, we would need to override it. But I'm just going to say it's not different. And if we look at them, the gas car has the compute tax plus $5, right? The electric car does not have the compute tax method. So what it'll do, it'll look at the superclass. So it'll look at the car's compute tax method. Car does have a compute tax, and so it'll use this for the electric car. And then this is how you make them. This is how you construct them. You print them, do anything you want. One thing you'll notice in car, we have this drive method, right? But in gas car, we don't have it. In electric car, we don't have it. But because car has this method, that means they're automatically included in the subclasses. So we can still drive them. We can have this electric car dot drive 2 miles. We can have this gas car dot drive 3 miles, right? And it works just fine. There we go. Compiles and works just fine. And if we look at it, see the electric car started off with that many miles. And if you look at after we drove it and then we printed it out again, yep, it went up by 2 miles. The gas car started with 2, 3, 4, 5 miles. We drove it 3 miles and then printed. And yep, it's 3 more miles. Okay. So that's it is a complicated subject, but that's all there is to Java encapsulation and inheritance. So that's what your assignment this week is geared towards. Really, you can take these principles that we've done here this morning, this gas car, and electric car, and you can really modify them to fit what your assignment is, which is talking about a snack as the superclass. And then you have a salty snack, I think, and a fruit snack. That's like your electric car and your gas car. So the salty snack, it is a snack, it's just a more specialized snack. A fruit snack is a snack, it's just a more specialized snack, right? Okay. That's all I have to present this morning, so I'll go ahead and open it up for questions.
When you added the semi truck class and extended the gas car class, is that common practice to extend derived classes, or is that kind of not really used as often, like in the workforce?
Oh, it is absolutely used. Let me see if I can show you a quick example. It's extensively used is where you can keep inheriting for 10 classes or something if you want. Let me see if I can find a quick example. Oh, actually, I need to open it up in here. I'm just going to show you one of the Java documentations. If I can copy and paste this over. Yeah, there we go. For example, in Java, there's an input stream. It's how you can get input from the user, right? This is just documentation and you can read it. So Java has this class called input stream, and input stream inherits, it's a subclass of object. That's kind of what this looks like. So object is actually the base class for everything in Java. Everything inherits or is a subclass of object. You don't have to specify that. It just kind of happens automatically. But so input stream extends object, but input stream is the superclass for all of these. So if I look at, say, this file input stream, so this file input stream is right here. It extends input stream, and input stream extends object. So I mean that's just one small example, but yes, you could have these where it goes on for a while, and it really just depends on how specialized you're trying to get down to the final class, I guess. But yeah, it is extensively used to where you have multiple layers of that inheritance going on.
Thank you.
I'll say you should not need anything that complex for any of your assignments for this class, but it is possible. All right, I'll stand by for about 1 more minute for any final questions. As I said, this will be posted up a little bit later today, and I'll get the link sent out so you can review at your leisure. All right, nothing heard. I'm going to go ahead and wrap it up and have a good rest of your weekend.